What's up guys, and welcome to the PHP backend tutorial. And in this tutorial we're going to go through the last part of the intermediate tutorials before we go on with the part 28. So in this section we're going to talk a little bit about callables, how you use closures, and something called higher order functions. And I think we're going to skip the tail recursion because we don't have enough time, and recursive programming. And since we do this, I suggest you read up on tail recursion and what that is and how you should be using it and how you, more importantly, should not be using it, because you can blow the back stack, basically where you put too many recursive calls successively, and how tail recursion can help you in some languages to deal with this. So if you're interested in recursive programming, mostly intuitively I would say that the mathematicians out there will be interested in this part. So if you consider yourself a math person, you should definitely look into this, because this will be important for you in your career as a mathematician. And if you're not interested in it at all, no worries. You don't need to know it in order to continue with the tutorials. So don't worry about that. And just remember tail recursion and recursive programming for now. So we're going to start with callables, which is kind of an interesting topic. And one programming language that uses callables, closures, and higher order functions is Lisp. And if you haven't heard about the programming languages called Lisp, I really suggest you just pause the video and go ahead and just like Google around about the history. You can check out the Wikipedia article about it and see. It's a really old language. It's actually one of the first programming languages. They built specifically designed hardware for this back in the days, even before, like, I don't know how many years before I personally was born. So this is something that is not quite new if you expressive, if you're conservative in your expressions, I guess. But anyways, it's been there for a couple of years, and also for a reason, basically. So yeah, enough with the ranting. We're gonna go ahead and check out how callbacks and higher order functions works. So I have made this super simple scenario where we have a function called calculate space needed, and you give it a size and you give it a strategy. Well, actually, skip the strategy for now, and we just have the size. So what this does is it gets the size from the user input, basically, and it checks if you work in a 2D environment or if you work in a 3D environment. And if you work in 2D environment, you're going to calculate the 2D space, so I don't know, like height times width. And if you work in a 3D environment, you're going to work with like height times width times depth. And it's assumed that it's cubic, of course. I mean, this is just an example, basically. And what if there's more than 3 dimensions? Whoa, everything's gonna go crazy, like some exception handling, I guess, in here. So what I'm trying to demonstrate here is like this if-else statement, basically, that you can have multiple cases where you need to check every time what kind of dimensions you're working in. And the problem with this is that, I mean, this is just a super simple example, obviously, so it's kind of forced. But what if the dimensions would switch? What if you switch from a 2D environment to a 3D? Then you need to check it every time you calculate the space needed. And that's kind of like inefficient, and also it would degrade your code that you will all the time need to check what kind of dimensions you're working in. So that's a problem that we're trying to solve, and the solution for it, we're going to look at higher order functions. So you should focus on these 3 functions right here. So as you can see, I created variables this is important part to understand, that these are actually variables, and these variables, the squares, get square size, the get cubic size, and the get default size, these are actually variables, and they contain a function. So I could, for example, say 33 in here, and it will be a variable, and in the same way I could assign it a function like this. So get square size is actually a variable that I can pass along to some functions, which I'll do later. And it contains a payload, which is the function right here. And I define three of those. I have a square size, I have a cubic size, and I have a default size. So the square size is just like width, height. The cubic size is like width, height, depth. And the default size is just linear. It's gonna one dimension, basically. It's gonna return the size. So I have these strategies. Let's call these strategies for now. Strategies, right? Something like that. And then we're gonna consume these strategies later. So I have a calculate space needed, and what it does, it takes the size and it takes a strategy as an input, and it's gonna call that strategy with the size, and it's gonna return the value. And I don't know why I duplicate this. And what you can do is you can get the size from the user input. So let's say that this returns 33 for now. And then you can also select its strategy, which is going to determine which one of these variables we're going to use. And you store it in an intermediate variable called strategy. And then you can call this function. You can pass along the size that we got from the user, and we can pass along the strategy that the user selected. So let's see an instance of this use case. So in here, calculate space needed. We're going to pass along 33, which is this size. And we're going to pass along a strategy, which might be, I don't know, cubic size, like this. And what's going to happen when you do this? Let's say that this is an actual execution of the program right here. So you're going to call this function with 33. You're going to give it a size of 33 and a strategy of get cubic size. So in here, it's going to pass along the strategy, which is going to be the cubic size. And then I'm going to give it the size, which is going to be 33. So in here, it'll be 33. And it'll be 33 times 33 times 33. And this is called something, this notion of passing along functions like this is called higher order functions. And this notion, this name, higher order functions, you should really remember, because it's gonna come back to you in your career as a software developer. If you haven't heard it before, you're gonna hear it, I guess. And one of the nice things about this is you can also change the strategy during runtime. So you could pass along, you could start with the default size like this. And then you can do some other kind of execution where you pass along some other strategies. I don't know, like you can change strategies, super simple during runtime. Just pass along some other parameter in there. And yeah, I don't know, it'll get different results each time. It's going to return the result here. Like this. It's going to be, this is their first result. This is going to be the second result. It's going to be a third result. And this one is going to be a linear result. This is going to be a cubic result, and this is going to be square result. So I hope that was too confusing for you. And also, I found this really good article about higher order functions in Lisp. So I'm not sure if this is going to confuse you even more or if it's going to help, but I'll put the link in the description. You can check it out if you like. And also, I suggest Googling higher order function, check out other YouTube material that's out there because there might be better explanations for it than the one I did. And I hope that makes sense to you in the end. So that was the higher order functions. And callables, you know what? When we pass along a variable like this that we did in here, that's called also callable. And there is a invoke function, which is a magic method in PHP that I talked about in the previous tutorials. You can backtrack and check that out if you want to know what a callable and the invoke is. And let's have a further look about the callables. So let's say that we have some kind of asynchronous operation that's supposed to be running. So it's not synchronous, it's not like this line executes and then another one line executes and the third one and so forth. So there might be some threading in here that, I don't know, for some reason we need to call a callback whenever we are done. So what we can do is whenever we call this function, it expects one parameter, right? It expects the callback. And we can pass the function immediately in here, like this. We just define it in here, function, like this. You can see the prototype for the function, right? And this is called a callback, and it's widely used in JavaScript, for example, because the nature of JavaScript is very asynchronous, especially in Node.js. If you're not familiar with it, I can tell you that it's super asynchronous. Everything is asynchronous basically in Node.js applications if you build it properly. So I hope you got it, like how we pass along a parameter in here, the callback that it expects, and we just give it a anonymous function basically. So it'll go ahead here, right here, do the threading, and oops, sorry about that. And whenever it's done, it's gonna call this callback that's being passed along, and we're gonna end up here, basically. So that's what a callback is. But we might have some problems. Let's say that we have some kind of variable, and oops, sorry, pure reflexes there of saving. So let's say we have some kind of variable out here that we need to use inside this right here. You might be tempted to use like just basically use it in here. Well, the problem is you cannot use this variable inside of this function that we define right here because this is not the same Clojure. So this function right here, the anonymous function, is called a Clojure. And also there is actually a programming language also called Clojure, which is a dialect of Lisp that I mentioned previously, which is obviously confusing, but and it's built entirely on top of this. How should I express it? The Clojure language is built entirely on top of this notion of closures, basically. Well, if that doesn't make sense to you, just ignore it. Basically, this is called a Clojure. This right here, the anonymous function, and that means that it's its own kind of scope where you cannot use stuff outside of the scope. So there is a workaround to it. If you need to use this variable in here, you can use the use keyword like this, and you give it the parameters, and you define the name, which is in this case it's called size, and now you're all good to go. But if you expect it to be changed right here, so let's say we assign it to another value right here, it's still going to be 22 out here. Because when you use the use keyword, it's going to be passed along as a copy. So you can use the value in here of the size if you like in the Clojure right here. But you will not be able to modify it inside the Clojure unless you pass it as a reference, which I'm not going to show you how to do because it's good to know how to do it, but in this case you'll probably just mess up and pass along with a reference. And that is if you pass along, well, actually let me show how it works. You can also put an ampersand right here, and that means that you'll pass along the actual reference to the location of the stack where this variable is located. So this will mean that if you modify it in here and give it another value, it's actually going to change outside the scope. And I don't really recommend that you do this unless you actually know what you're doing, because when you do stuff like this, you're going to have something that is called side effects, which is also a super important thing to know about. So like the keywords here is Clojure and higher, well, callbacks, well, callbacks. And in the previous tutorial, I talked about higher order functions, which is also a important topic, of course, and pass as reference versus pass as value. And the last one that I did here with ampersand is pass by reference. And side effects. And side effects basically means that you should try to avoid side effects basically. When you pass something along, like I did the first time, and I assign it a new value, it's still gonna be 22. This implementation right here doesn't have any side effects, which makes it more predictable in the way it operates. But as soon as I pass along an ampersand here and pass it as a reference, it's going to modify the state of the variable, and it means that it has side effects. So that's the terminology of it, basically. So, well, let's hope that was not too confusing to you. And I'm gonna put some material for you in the description so you can read up on it. And please, as I said before in the previous comments, previous video, sorry, please leave a comment if something is confusing to you. And I know that this was also a bit confusing, this video, and I really rely on your comments and feedback on my videos for me to make higher quality material for you guys. And that's my only way to improve, basically. So I hope you guys liked it, and I hope to see you in the next tutorial, which will actually be the part 28, where we go into the implementation of middleware, which is super important, super exciting as well. So I hope you guys liked it, and I'll see you in the next tutorial. See you, bye.